Hello everyone. Let's continue to the last topic, outer joints. We have learned the natural joint in the previous lesson. Natural joint requires that both left and right tables must have a matching two-pole based on the common attribute. Air natural joint S equal to the projection air union S attribute from the selection operation on common attributes air.a1 equal to s.a1, air.a2 equals to s.a2, and so on, from the Cartesian product of the air cross S. However, if a common attribute has a null value, those two poles are excluded from the joint result. To display rows in the result that do not have matching values in the joint column, we use outer joints. Outer joints is an extension of the joint operation. It's designed specifically to handle missing information. When there's missing information, it's represented by null values in the result. Null values in the database mean unknown or unspecified value. It doesn't mean zero. Outer joints ensure that even when there is a missing data, we can still include relevant rows in our query results. Let's explore the three different types of outer joint. Left outer joint. It is denoted by the symbol air left outer joint S. In a left outer joint, if a tuple T air from relation air doesn't match any tuple in S, the result will contain Ts from relation S null. If a tuple Ts from relation S doesn't match any tuple in air, it is excluded from the result. It simply includes all tuples from left relation. Even this tuple doesn't match any tuples in the right relation, and missing information of the right relation is represented by null value in the result. Second type of outer joint is right outer joint. It is denoted by this symbol here, right outer joint S. In the right outer joint, if a tuple T air from relation air doesn't match any tuple in S, it is excluded from the result. But if a tuple Ts from relation S doesn't match any tuple in air, the result will contain null Ts. It simply includes all tuples from right relation, even these tuples doesn't match any tuple in left relation. And missing information is represented by null values in the result. The third type of outer joint is full outer joint. It is denoted by this symbol, air full outer joint S. In a full outer joint, the result includes tuples from air that don't match tuples from S, as well as tuples from S that don't match relation air. It simply includes all tuples from both relations. Even these tuples doesn't match, and missing information is represented by null values in the result. This ensures that no information is lost from either relation, giving us a complete picture of the data from our databases. Let's see example of outer joint operation, and you will understand a lot better. Example, consider the two tables air and S here, where air contains attribute 1 and attribute 2, and S contains attribute 1 and attribute C. The common attribute between air and S is attribute 1. First operation, air natural joint S. Natural joint requires that both left and right tables must have a matching tuple based on the common attributes that have matching values. If a common attribute between air and S, attribute 1 from air, matches attribute 1 from S, the tuple is included. If a common attribute has a null value, those tuples are excluded from the natural joint result. The first tuple from air, A and air1, is not included because A doesn't match any tuple in attribute 1 from S. Second tuple from relation air, B, air2, match the first tuple of S, B, S2. The third tuple from air, C, air3, match the second tuple from S, C, and S3. That's all tuple from air. In relation S, the last tuple is not included because no tuple from air match with the attribute 1, that is D. The result from air natural join S is the two tuples. Second operation is air left outer join S. The result of air left outer join S will include all three tuples from air, matching the tuple in S. If a tuple TS from relation S doesn't make any tuple in air, it is excluded from the result. The first tuple A, air1, doesn't match any tuple from S, so there is a missing value for the attribute 3, and it is represented by null value. For second and third tuples, they included the matched tuple from the relation S as presented in the result. The third operation is right outer join S. The result of air right outer join S contains all three tuples from S. If a tuple TS from relation S doesn't match any tuple in air, it is excluded from the result. The first and second tuples are matching tuples. For the last tuple D, it doesn't match any tuples in air. So the column attribute 2 in air has a missing information and it is taken null value. The third operation is air full outer join S. The result of full outer join consists of all tuples from air and S, even though tuples from air that don't match S as well as tuples from S that don't match air. The first tuple from air, A, air1, doesn't match any tuple from S, so attribute 3 is null. The second tuple from air, B, air2, matches the first tuple from S, B, S2, so attribute 3 is S2. The third tuple from air, C, air3, match the second tuple from S, C, S3, so attribute 3 is S3. The last tuple is from the relation S, D and S4. It doesn't have any tuple from air, so the attribute 2 is null. That's all about the outer join operation. Hope you have a clear understanding of outer join operation. Practice exercise. Consider the two relations, people and menu. What will be the output of resulting relations from each operations below? Pause the video for a moment and try to solve the following practice exercise. After you given it a try, you can resume the video to see the solution and check your answer at the end of the video. Null values. What exactly is null? Null represents something that is unknown or non-existent in our data. It's like a placeholder for missing or undefined information. But here is the thing. Null values can have a significant impact on our database operations. We must always be aware of their presence and specify how they affect our results. When working with null values, it's essential to consult our database user manual for guidance. Understanding how null values behave in our specific database system is key to working with them effectively. Let's dive into Let's look into a couple of important points about null value. Firstly, in arithmetic operations like addition, subtraction, multiplication, and division, involve null values always result in null. For example, 5 plus null equals null. It's as if the presence of null makes the outcome uncertain. Secondly, in comparison operations, null value leads to an evaluation of unknown. Unknown represents a third truth value alongside true and false. Surprisingly, even comparing null to null results in unknown. It's like trying to compare two unknown things. We simply cannot determine if they are equal or not. So what's the takeaway from all this? Null values are something we must handle with care in our database operations. They introduce uncertainty and can affect our results in unexpected way. By understanding their behavior and specifying their effects, we can navigate our databases more effectively and ensure the accuracy of our results. Boolean operation, Boolean operator and unknown. Boolean operators and unknown or null. Let's see what will be the result of Boolean operators with null values. First, let's take about the AND operator, denoted as way symbol. The result is true if only if both condition is true. First, let's talk about the AND operator, denoted by this symbol. In the AND operation, the result is true if and only if both conditions are true. True and unknown will equal to unknown. When we combine true with unknown using AND, the result is unknown. When we don't have all the information, we cannot say it is true or false. When false and unknown will equal to false. Logically, when we combine false with unknown using AND operator, the result will definitely false, because only when both conditions are true can the overall statement be considered true. Now, when unknown and unknown, the overall statement remains, of course, unknown. Next, let's explore the OR operator, denoted by the symbol. When we combine true with unknown using OR, the result is true. This is because having one true condition is enough to determine the overall truth of the statement in the OR operator. On the other hand, when we combine false with unknown using OR, the result remains unknown. Again, it's the uncertainty introduced by the unknown value that affects the overall truth of the statement. And when we have two unknown values combined with OR, the result you get remains unknown. It's like trying to determine the outcome of a situation when we are unsure about all of the factors involved. The result remains uncertain. Lastly, let's discuss the not operator, denoted as the symbol. When we apply not to an unknown value, the result is, you can guess it, unknown. This is because negating an unknown value doesn't provide us with any new information about its truth or falsehood. This is because an unknown value doesn't provide us with any new information about it, whether it is true or false. So when we use not with unknown, it is unknown.